water takes less time to get to the cross-river section. So basically the duration of the rainfall, of the critical rainfall, is strictly linked to the time that takes the catchment to fully contribute to the river flows. And there is a characteristic time for each catchment that is called concentration time. In Italian it is called tempo di correlazione. What is the time of concentration or concentration time? Is the maximum time, I repeat afterwards, the maximum time required by a drop of rain to reach the closure of the catchment. Again, concentration time definition is the maximum time taken by a drop of rain to reach the closure of the catchment. The closure is the cross-river section that identifies the catchment. So let's think to this definition. What does it mean? The maximum time taken by a drop of rainfall. If I say that the concentration time is 2 hours, it means that after 2 hours of rain, the whole catchment is contributing to the river flows. Because 2 hours is the maximum time required by a drop of rainfall to reach the closure. It means that any point in the catchment is contributing to the river flows in the closure. So people realized that the critical duration of rainfall is equal to the concentration time. They realized that we should put in the rational formula a rainfall intensity that corresponds to a rainfall event that has a duration that is equal to the concentration time. I repeat, people realized that we should put in the rational formula a rainfall intensity that has a duration that is equal to the concentration time. It can also be proved mathematically under certain conditions which are reasonable, that indeed this is the critical rainfall for the peak flow, meaning that if you try to put in the rational formula a rainfall with a lower duration and higher intensity, you get a peak flow that is less significant. So now the question is how to estimate the time of concentration. And here you see the definition and a table that gives to you some order of magnitudes for runoff coefficients. It is not really useful to know this, because you know a watershed is not homogeneous. So if you see that, for instance, for downtown areas, C is varying between 0.7 and 0.95, and you look at the catchment is diverse. The catchment is not just one type of area, it's a mix. But in any case, to know these orders of magnitude is useful. And this is something I may ask you, like, give me an indication of the runoff coefficient. If you see a basin that is impervious, what is your guess for the runoff coefficient? If you see a basin that is completely urbanized, and your reply should be something around 0.7 and 1. Or I may say, if you look at the catchment, which is fully covered by vegetation, what is your guess? And you should say something between 0.2, 0.5, 0.6 at most. And then time of concentration. These are some empirical formulas to estimate it. And please note, there is no way to estimate the concentration time more reliably than these empirical equations. And therefore you can understand that the concentration time is something which has a well-defined physical meaning, but it cannot be estimated with reduced uncertainty. You always have a very significant uncertainty, because if you look at this empirical relationship, you will see that they are very general, and they are not easy to read but at the blackboard, but if you download the slide, it's easy to read. And also, let me see, the most used formula in Italy, let me see, no, it's not here. So let me write just to close, the most used formula in Italy for the time of concentration. It's Giandotti's formula. And it's written as concentration times in hours. It's equal to, it's an empirical formula, so don't be surprised. It's 4 times the square root of A in square kilometers plus 1.5 times the mainstream length, capital L, in kilometers, divided by 0.4 square root of h, and h is expressed in meters. What is h? H is average altitude with respect to the river cross section. WRT closure. Average altitude, WRT closure, with respect to closure. And again, unit measures: hours for the concentration time, square kilometers for the basin area, kilometers for the mainstream length, and meters for the altitude. And you see that it's empirical because it's not dimensionally homogeneous, and you understand that it's for sure uncertain, this relationship, because it computes the time of concentration depending on only 3 parameters, which are for sure reasonable parameters: extension of the basin, mainstream length, and altitude, which is a surrogate for slope, and therefore a surrogate for flow velocity. But of course this is very empirical and it cannot be precise. It cannot be but uncertain. But in any case, this is widely used in Italy. If you try to make a comparison between this formula and all these formulations, you find differences of the order of 20 to 500%. So basically, to estimate the concentration time is really a challenge. But indeed, this is a first example of a rainfall on a flow, which gives to you an idea of the subject. Basically, it's a black box relationship between rainfall and runoff with some physical implication, because we will see that it can be seen as a mass balance equation under very simplified assumption. Simplifying assumptions. Okay, that's fine. Tomorrow I will move forward with the theory for just, let's say, 15-20 minutes, because I want to introduce the rain transport theorem, and then we will turn to the PC and R. Okay?